Hello everyone, in this video I will be going over the implementation of image classifier on the mango leaf disease dataset using various classifiers like CNN, random forest dysentery, KNN, naive Bayes and others. So let's start with this. So first we'll import all the necessary files or libraries. Then we will set a data directory where our data is present. This is we have image count. I am just checking is all the data is present or not. Later I am checking like all the data set in each class, the data set is there or not, checking one by one. Just one image is enough. So that for each class you can see like for call image I have showed one image, for healthy leaf is there one image, powdery mildew is there, and so on. Later on we decide the batch size. For me it is 64. Then we'll take on the image height and width, that is 240 by 320. Then we'll create a then we'll split the data set into training data and the validation data. For in my case, which I'm taking as like 90 to 10%. So 90% is the training data, 10% is the validation data. As you can see, like out of 4,000, 3,600 of files are being used as training. That is 90% of it. And for validation, I'm using only the rest of the 400 files, which is 10% of the 4,000. Here I am showing all the categories or classes which are available to me in the training data, all the different classes. Now let's start with the CNN model, the first. So this is a basic CNN model, as you can see, with the basic ReLU activation. This is out here. Now here I am compiling it, all the compiling the first CNN model. This is a summary of it. And this is the flowchart, how the CNN model gonna work. So like input level is gonna have 240, 323. Descaling we did, it's same as 240, 320 because we didn't change the size. Then convolution layer will have like change the 3 to 16. So max boolean will have like 16 to 16. Then again like that we have changed it to 64 bit. And the image size has been reduced by 60 to 80. Here I am training the model for 10 epochs. As you can see here we are getting the accuracy around 93% in the training. This is here we are plotting the graph between the training and validation accuracy and validation training loss as well to compare them. Then also I have created another CNN model where I am experimenting with the convolutional pooling pairs. Here we will create the pairs of the convolution layers. So this is like the first pair 8C5, so like it has 8, kernel size is 5, and we have the same input shape is here. So this is like first. Then we'll create another convolution layer with 16 convolutions, and the kernel size again it's 5 only. Later we have the convolution layer of 32 and then 64. Like that I have created 4 convolution pairs in this. Now let's see how the test goes. So here we are having the validation accuracy of 86%. As you can see, it's not as much as good as the CNN model, the first model we have created, but it's still okay. So here we can see the graphs and data that the training loss is very high. Now we will split the data into X-train and Y-train so that we can use it on another classifiers like random forest and others. So that's what we are doing here. We are converting them in a proper X-train, Y-train format. And the data has been changed to new numbers now rather than images. So they have numbers. You can see it here as well. So the first is our random forest classification. For that we are getting 87% of the accuracy. Then we are using KNN classification. Here we are getting the accuracy of 63%. For decision tree we are having 67%. For Gaussian naive Bayes we have 56% of the accuracy. Now let's compare all the 6 models that we have. So out of the 6 models we can see CNN model 1 is much better than rest of them. So that's all. For more details you can check it on my blog, which would be in the description. Thank you guys. Please like and share.